Hey, it's time for us to do an exam paper. We're going to try and do a GCSE Maths paper. This is, for anyone not in the UK, this is the exam that the 16-year-olds sit in at the moment. The GCSE takes 3 papers, one of which is a non-calculated paper, two of which are calculated papers. Each one is an hour and a half. So we're going to try the non-calculated paper, and I'm doing this with my friend and colleague and fellow Mathmo, Tom Crawford. If you haven't seen Tom before, check his videos out. He's got all sorts of amazing videos all over YouTube. Stars himself as the naked mathematician for various reasons. I'll let you figure that out. He is also going to try this paper, and just for clarity, neither of us have looked at it in advance. We agreed on a call yesterday that we're going to try the Summer AQA 2009 paper 1, the non-calculated one, and we're just going to record ourselves doing it, and we're actually going to send each other our scripts and get them marked and have a hilarious time discussing what went horribly wrong. So without any further ado, I'm going to dive straight in. I've got the paper on a OneNote file here, so I'm just going to scribble straight onto it. I haven't actually got loads of other kit. It's a non-calculated paper, so I haven't got a calculator near me. I did pick up a ruler. It's pretty dusty and old, just in case. I should still be able to use that on my... so I'm writing on my Surface device as well, which I probably just messed up the recording of. And we're just gonna dive in. I'm gonna start a timer, and we'll see how long this takes. According to my clock on my computer, it's 12:13 now. So let's see if we can get this done. I officially have an hour and a half. Let's crack on and see what happens. So I should write my name, shouldn't I? I'm gonna choose a better pen. That would be a helpful thing. In fact, what I'm probably going to do is change the background so this is actually bright all the way, and we'll work in blue. I'll call myself Ben Sparks because that's my name. Oh, I've got to sign. I'm not going to give you my signature. Don't have a calculator. I must have mathematical instruments. See how we do without that. I can't do pencil on this or pen. We should be able to rub out. We'll be fine. And let's see how we're going. So here are 2 right-angled triangles. Good to know. Not drawn accurately. Circle the value of y. Okay, we've got an angle. It's basic trigonometry or ratio, and they're similar, right? So the angles are the same, so it's scaled up by, multiplied by 1.5, so we're going to get 9. Move on. Work out the value of 1 2/3. I hate mixed numbers. I really hate writing 1 next to 2/3, like, because it could, in any other situation, I'd kind of think as 2 things next to each other as multiplying, but this is now adding. So 1 2/3 is like 1 plus 2/3. Anyway, 1 is 3/3, so this is 5/3 to the power of 2. Pretty sure that's right. Square that, you're going to get 25 over 9. Do I need to do... Yeah, turn that into a mixed number. Yuck. 9, we're going to get 18 over 9, and whatever's left is a 7 over 9. So I think that's a 2 and 7/9. I'm using the plus symbol, but they've written it like that. Mixed numbers. I think we should not use them. Hey, never mind. We've got to understand that other people might use them, and that's maybe a good reason to have them on that exam. Question 3. Work out the arc length in meters of a semicircle radius 6 meters. Draw a picture. That's an amazing semicircle. I'm very happy with that. Radius 6 meters is there, and I want the arc length, not the full perimeter, so I need this distance. Well, the full distance around a circle is 2 pi r, and half the distance is therefore going to be just pi r, so it's 6 pi. Just check and have done anything stupid there. I think that's fine. Let's keep moving. Circle fraction that is equivalent to 4.625. Well, if I was going to do this in detail to make sure I don't mess it up, first of all, 4. So if like 32 would be sensible. Anyway, 625 over 1,000 because it's 625 thousandths. Is there a sensible? I mean, it's 125, which is, I think, an eighth, right? Over, so it's 1/8 more than half. So there's 5/8, I think. Which means it's 37 over 8. So it's strange that I'm struggling. I don't have a method for this. I just know that 4.625, well, this is, if I divide everything by 5, say, I'm going to get 200. 625 divided by 5. I feel like it's going to be 100. It's amazing what your brain does when you know you're being filmed. So dividing 500 by 5 would be 100. And I've got another 25. 125. Okay, and divide that by 25. You're going to get 5 of them, and divide that by 25. You're going to get 8 of them. Yeah, it's 5/8. So it's 4 and 5/8, which is 32 over 8. Fractions. Let's go with that. 32 plus 5 is 37. Right, 0.00097 in standard form. So that's times 10 to the something. So that's 9.7 times 10 to the something. And all I need to do is figure out what the something is. And the classic thing is I've got to multiply 9.7 by something negative to make it smaller. And so if the decimal point is in there, it's going to go 1, 2, 3, 4 positions. And people argue about whether you should talk about moving the decimal point. I'm scaling it bigger by 10, which does visually move the decimal point. I don't think there's a problem with talking about it. Did I count? Hold on. 1, 2, 3, 4. So that's 10 to the negative 4. Pretty sure that's right. Let's just go with that. Work out, whatever that means. Does that mean calculate? Work out 3 times 10 to the 5 over 4 times 10 to the 3. Well, it's 3/4 times 10 to the 2, because 5 take away 3 is 2, and it's 10 to the power 5 divided by 10 to the 3. Anyway, that's as an ordinary number. Is this technical language? So 0.75, if you prefer, times 10 to the 2, which is 100. So 750. No, times 100, 75. And if I just wanted to check on this, it's 3 times 10 to the 5, so 300,000 over 4,000. And this is another way of sort of just dealing with it. It's 300 over 4, which is 75. Let's just go with 75. I should trust myself, and I'm going to keep moving. I'm hoping to do this in less time than I would need. We'll see. Anna plays a game with an ordinary fair die. Dice? Die? Doesn't matter. It should be die, right? They've changed the word in the paper. That's interesting. If she rolls 1, she wins. 2 or 3, she loses. 4, 5, 6, she rolls again. When she has to roll again, then second roll. What a strange game. Rolls an odd, she wins, and even, she loses. Tree diagram. The 4 missing probabilities. Okay, so if she rolls a 1, she wins. I'm just going to write a win there. If she rolls 2 or 3, she loses. I know it didn't ask me for that, but then odd, win, and then loss. What else have we got? The chance of getting a 1 is 1 out of 6 if it's a fair 6-sided die. I presume. They just assumed ordinaries are 6-sided. Fine. We'll stick with our cubes. No tetrahedral dice or anything like that. Or octahedral, since we go up to 6. Anyway, 2 or 3 is definitely 2 out of 6, otherwise known as 1/3. And if we roll the other 3, that's a half, and then odd is a half, and even is a half. So I'm pretty sure those are the numbers they want. 2 marks for that. Okay. Is Anna more likely to win or lose? You must work out the probability that she wins. So why don't they just say, what is the probability she wins? Interesting. Okay, so to win, we've got 1/6 to get here. And then we've got, multiplying along this row, we've got half times a half, which is a quarter. So I think we've got a quarter of a win. Sorry, the win is a 1/6 plus a quarter. If I do that in 12ths, that's the easiest thing. So 2/12 plus 3/12, I think, is 5/12, which means just less than half. So I think she is less likely to win than lose. Let's just check. This is a 1/3, and this is a half. Let's just do a probability of a loss then. We'll try and do it in full. Maybe I would be in more of a hurry if I was actually doing this. So I said a 1/3 plus a half, yeah. And we turn those into 6. We've got 2/6 plus 3/6 equals 5/6. And why am I worried about this? Something's wrong. What have we done wrong? Oh yeah, so that's not a half at all. That's another quarter. Careful. That's not a half. That's a quarter. I think this is now working out, isn't it? So let's go with 12ths on this one as well. That's 4/12, and that is 3/12, and altogether that makes 7/12, which is the rest of it, the complement of these two. So lose more likely. I think that's the answer they wanted. Let's just check the wording again in a minute. Is Anna more likely to win or lose? Lose is more likely. I don't think anyone can argue with my work in there, and I've worked out the probability of win and lose, so I don't think anyone can complain about the number of marks there. Let's hope. Question 7. 3 friends arrive at a party. Their arrival increases the number of people by 20%. In total, how many people? So we had, let's go with X is the number of people. Let's fill up right at number of people at party to start with. And then X plus 3 when 3 arrive. And that's the same as it was, increased by 20%, multiplied by 1.2. So it's a little equation to solve for me now. I don't think it's going to be too bad. I'm going to take away x from both sides. I've got 3 left on this side, and I've got 0.2x. So I've got x equals 3 divided by 0.2, which is 3 divided by a fifth, which is 15, which is 3 times 5. So x is 15, and 3 people is 20% of that. Yeah, I could have just gone with that. So now at the party, we've got 18 people. I'm pretty sure about that. I'm going to keep going. Work out the value of a random calculation. I guess it's testing whether I can deal with powers and indices. And yeah, good thing to test. It just feels so like mundane and out of context, but it's just checking skills, all right? And maybe that's partly what exams are for. So let us do... let's write this properly. I really hate those divisions. This is called an obolus, I think. And they just confuse issues. So it's 3/12 over 3 to the power 12 over 3 to the 5, and all of that divided by 3 squared times 3. So let's just tidy this up. On the top, we've got 3 to the 7. Doing the subtraction thing. On the bottom, we've got 3 to the 3. Got a bit of hair on my page there. And tidying that up, that's 3 to the 4, which is 127. 3 times 3 is 9, times 3 is 27. Yeah, it's 81. I wonder if I'd left it as 3 to the 4, whether I would have got all the marks. It's possible they wouldn't have done, but they didn't tell me what sort of number to write it in. And that would imply they didn't even... I could just write down the question and they have to give me the marks. Yeah, so they are going to ask me to get an actual number, probably. Anyway, I think that's 3 marks. Question 9. A shaded semicircle is inside a circle. Good to know. As shown, not drawn accurately. Radius is 10 of the circle. Diameter of the semicircle is 8. So I'm going to put a 4 on here. Radii are useful. How many times bigger is the unshaded area than the shaded area? Well, if these things were movable, I'd feel like it's just a circle. But then you put the shaded thing inside it and that removes some of the unshaded area. I presume that's why they're doing this. It's not quite as simple. So well, let's sort out the shaded area first. Shaded area is a semicircle. The area of a circle is pi r squared. So this is a half pi r squared, and r is 4, so it's a half pi times 16, otherwise known as 8 pi. And the unshaded area is going to be the circle area minus the shaded area. So it's pi times 100, that's 10 squared, minus 8 pi. So this is 92 pi. How many times bigger is the unshaded area than the shaded area? So I need 92 over 8. Well, 10 times 8 is 80. So it's not going to be an exact number. That slightly disturbs me, but maybe I shouldn't expect exact numbers. 92 over it. Let's do it the long way. If I was struggling under pressure, you've got to have some backup things. So if you divide everything by 2, you're going to get 46 over 4. Divide that by 2, you're going to get 23 over 2, otherwise known as 11.5. 11 times 8 is 88. Yeah, so I think that's true. Unshaded area is pi times 100, pi r squared. Take away the 8 pi. Let's just check the 8 pi. So that's a half of pi times 4 squared. Yeah. Stick with it. Turn over for the next question. Not going to do that because I'm on a scrolly screen. No turning over for me. Hope that was funnier than it sounded in my head just then. The number of items n. I don't get marks for making jokes in exams, do I? Sorry, Tom. The number of items n made in 1 hour by a machine is given by n is 60 over t. T is the time in minutes the machine takes to make one item. Okay. The value of t changes for different types of item. Well, that's good to know. On the grid, draw the graph of n equals 60 over t for values of t from 1 to 4. So it would make sense to have a little table, but anyway, if t is 1, 2... Do I need to plot. Is t integers? No, not necessarily. Anyway, when t is 1, it's 60. When t is 2, it's 30. And t is 3, I've given a nice number, haven't they? It's 20, and divide by 4, you get 15. Draw the graphs. Presumably join them up. And it's going to go off to infinity. It's just it should be drawn in pencil, people. Missed. Okay, I've drawn a graph. Whether or not that would get the marks, I don't know. I don't know if Tom's going to mark me harshly for the fact that it doesn't tail off. But anyway, let's go like that. I'm off the edge of the scale there. The machine takes 3 minutes 30 seconds to make one item. So that's 3 minutes 30 seconds is 3.5 minutes. Use your graph in bold. So, okay, I've got to. Let's just get a new pen so they can see I'm being careful here. I've got to go up that point here. I should be using a ruler. Use a ruler, peeps. According to my graph, and it says to use my graph, that hits at, let's get this right, each little square is 2, so 12, 14, 17. Number of items. Oh, I've gone red. Never mind. Go back to blue. I think I've used my graph. I think it's visible enough on there. I should have used a ruler. I don't think they're going to penalise me. Using a ruler would only be helpful to actually just make sure I'm being accurate, but I think I can use the grid this way there. Anyway, question 11. Ed and Faye shared £330 in the ratio 7-4. Ed gives Faye some of his money. Well done, Ed. Faye now has the same amount as Ed, so now they're in the ratio 1-1. Okay. £330, and we've got 11 parts altogether, 7 of which are Ed's and 4 Faye's to start with. So 330, 11 parts, that's divided by 11, I think that's 30 pounds per part. Right, okay, well, let's just sort that out. So that means Ed has £210 and Faye has 30 times 4, which is 120. And we want to end up with equal money. So they're 90 apart. I think he needs to give 45. If we take this down by 45, take it down by 50 would be at 160. So it's 165. And put this up by 45, we get 165. So it was 90 apart. Give 45. I think that's my answer, £45. And that adds up to 330. Okay, let's keep moving. The next term of a sequence is made by adding the previous 2 terms. Fibonacci style, that's fun. 1 mark for this. Which of these sequences follow the rule? Okay, fine. -9, sorry, -9, I should say. -9 plus 2 is -7. And then -7 plus 2 is -5. And -7 plus -5 is -12. That looks like it's following the rule. Okay, -3 plus 5 is not -2. So that one's not. 0 plus -3 is -3, and then -3 plus -3 is not 0. So that's not following the rule. And -1 plus -1, it's testing negative number awareness, and it is confusing. I'm trying to say the word negative instead of minus to differentiate between a number which is negative and the operation of subtracting, like minus. Yeah, something minus something is a verb. No, is it? Oh, I'm getting confused myself now. Anyway, -1 plus -1 is -2, and -1 plus -2 is -3, and -2 plus -3 is -5. So that's not following the rule till the very end. So that one is following the rule. Okay, let's keep moving. Question 13. The triangular cross-section of a prism is an isosceles right-angled triangle. Okay, they've drawn it in a sort of irritating non-perspective way there, so I can see the right angle, but then it goes off into the distance, makes me feel a bit like I'm not looking at a real thing. Anyway, the volume is 102. Use approximations to estimate the value of x. Approximations? What are they? Okay, the volume of the prism is a half x squared, that's height times base, because they're right angled, times 8.14. Use approximations. Half x squared times 8.14 is 102. What do they want me to do here? Well, if I approximate 8.14 to 8, is that the official way of approximating? And approximate 102 to 100. So that we're rounding to one significant figure in all the numbers I've got. Then let's see what happens. So I'm going to get 8x squared is 100 over 8. Half x squared. Half that. Sorry, double that. We're going to get x squared is approximately 200 over 16. Is that nice? That's right. Careful with doubling here. 200 over 8. Which is 100 over 4, which I can square root to be 25 over 2. Otherwise known as 12.5. But maybe if I've approximated, I should be rounding that to one significant figure as well. So don't know what the rules of GCSE approximations are. But anyway, I feel confident that x is approximately 10 to an order of magnitude. No idea if they wanted a more precise answer than that. If it was 10, you'd get 50 for the side times 8. But I've sort of rounded everything down. Because I've rounded both of them down, it's very hard to tell. Let's say approx 12.5 to one significant figure, x is approximately 10. I don't know what they want here. I'm going to leave it like that. We'll go with one order of magnitude. Here is a quadrilateral question 14. Nice. I know some angle facts about quadrilaterals. It's very tempting to assume that's 90. Oh, it is 90. It tells me it's 90. Okay, that's probably fine. Let's say a to b is 5 to 3. That's the ratio of angles. It's a strange thing to do. X to y is 1 to 3. Okay, what do I know? I know that a plus b plus x plus y must equal 360. Is that how internal angles work? Yeah, because it's two triangles and the internal angles of a triangle add to 180, so that's going to be 360. Just checking my quadrilateral facts here. Ratios annoy me. I don't know why they annoy me. Anyway, what else do I know here? So I know a divided by b is 5 over 3. I'd far rather having them as fractions where I can sort of trust an equal sign. And I know x divided by y is 1 over 3. Show that b equals x. Oh, I know what a is. Okay, so let's replace a with 90. And I've got 3 facts and 3 unknowns. I mean, so I know there's a simultaneous equation way of solving this. Maybe there's an easier way to get through it. But I'm just going to bash through. Maybe sledgehammer cracking nuts here. So b is, let's sort this out, 3 times 90 over 5. Otherwise known as 270 over 5. Not over 10. That is 540, is that right? Over 10, which is 54. So B is 54. That looks believable. I know it's not drawn accurately, but hopefully it's not drawn deliberately inaccurately. And now I need to show that X equals B. Okay, so let's, 90 plus 54 plus x plus y is 360. Let's tidy that up. X plus y is 360 minus 90. Let's get this right. 90 plus 54 is 144. Better take that off. So that's 216 x plus y. Take 100, you get 260. Take 40, you get 20. Yeah, okay. And I also know that x equals 3x equals y from that one. So let's swap in y. I've got x plus 3x equals 216. 4x equals 216. X equals halve it, you get 108. Halve it again, you get 54. So b is 54, x is 54, so x equals b. Okay, I feel like maybe there was a shorter way through there, but the algebra worked out. 3 marks. I'm going to keep going. 15. Reading numbers. Here is some information about the test marks of 120 students. Okay, we've got a frequency table. I want me to do a cumulative frequency table, complete the cumulative frequency table, and we're just working up to the endpoints here, so that's fine. I'm just going to add these together. They've added those two together, that one. So I'm going to add another 40 onto that, which means 88. Another 20 on is 108, and another 12 on is 120, which is a relief because that should be all of them. So hopefully that's okay. Draw a cumulative frequency graph. And so we're going to plot these points at 10 and 20 because it's up to that point. So 10 goes with 20. Actually quite hard to, my alignment is very slightly off here. I'm going to be careful about this. 20 goes with 48. And looks like every one square is 4. 24, 28, 32, 36, yeah. So 48 is there. Again, I can't draw this accurately. I'm taking my time here. Anyway, 30 is 88. So that's another 2 squares beyond 80. 40, 108, another 2 square job. And then 50 at 120 exactly. So that's the cumulative frequency, and presumably it does start at 0. So I'm going to change colour and draw this quite carefully. I don't know what the rules are, whether you're meant to be using a ruler to join these up with straight lines or doing a nice curve in between. We're only going to be able to use it to estimate anyway, so hopefully that's good enough. Don't need to type, thanks. So that's drawn the graph. It's 2 marks. I have no idea what happens beyond 50. Maybe let's just get this one a little bit better. Don't know if that's better. 15. Students who scored 15 marks or fewer take another test. Hopefully I'm not going to be in that position. It's going to ask me to estimate how many students take another test, i.e. 15 or fewer. So the marks is along the bottom. That's 15 here. Let's go up to that line. It looks like it pretty much crosses on that line. Let's assume it does. We're estimating anyway. And that is 32. So I think it is the bottom 32 take another test. 32. I'm not sure what else I'm meant to write there. Okay, we're back into simplifying. Simplify fully. 4x minus 8x squared. Sorry, I was just checking the recording still. It looks like it is. Getting tired already. It's just algebra. Out of context, it's just checking your algebra skills. I can't see, there's no reason in this question why you'd want to do it. But anyway, it's a useful skill if algebra like this turns up in a longer problem you're working on. I'm going to factorize everything. Factorizing is almost always the way forward. I'm going to take out a 4 and an x from the top. I'm going to get a 1 and I'm going to get a 2 and an x left there. And on the bottom, I can factorize this 2. I can take a 3 out and I'd get a 4x minus 2. I can take another factor out. I should have spotted that. I could take a 6 out. So there's nothing wrong with not spotting it as long as you just keep everything else the same and take out another 2. So I'm going to get 6 out here. 2x minus 1. Interestingly, those brackets are the same top and bottom. If I was going to make it really clear, I would put a negative there and say that's 2x negative, subtract 1, and that's 6 over 2x minus 1. So I'm going to cancel them since they are not 0. And so I'll end up with a negative 2x over 3. And I think that's fine. Let's keep going. Question 17. Toby is forming and solving equations. Well done, Toby. I approve of your behavior. The product of half a number and 3 more than the number is the same as the square of the number. So write this as an equation. Almost certainly, yes. It uses y. Write an equation that Toby could form. Well, I mean, he could form anything if he doesn't mind about being right. Why am I picking on the language here? Anyway, let's do that a correct equation instead of being an idiot about it. Y over 2 is half of a number multiplied by 3 more than the number, y plus 3, is the same as, what's what equal signs mean, the square of the number. I think that's it. And I just haven't put it in the answer form. But anyway, you get the idea. Am I meant to solve it? Part B. Toby forms another equation. He wants to work out the values of x. Here is his working. So I don't need to solve it. If I have time, I'll come back to that. I don't think I will. They haven't asked me to solve it. It's just write down an equation. Or write an equation. It's not the write down, which is usually a clue that it's going to be super quick, but this says write. So it's 2 marks. I did it, I think. Toby forms another equation. Here is his working to solve it. Before I look at it, I'm going to solve it. I'm going to say x squared is the same as 9 over 8, and I'm going to square root that by saying x equals 3 plus or minus 3. Did I do a square root earlier without doing a plus or minus? Let me go and check that. Oh, we're doing lengths here. So I should ignore negative value for x. Yeah, but I didn't talk about it then. There's something lurking in my brain about that. Where were we? So that's what I would try and solve. X equals, and yeah, I could rationalize the denominator. Let's not worry about that. Why am I? Anyway, let's see what he's done. So he has multiplied by 8, and I think that's fine. He's multiplied by 8x, and that's fine. So that's, I'm going to tick that. He's there. Ooh, what's he done then? He's square rooted, but he didn't square root the 8. So here, when square rooting, this is like marking someone's script, isn't it? Toby did not square root the 8, and you need to do the same to both sides. You need to square root 8x squared, so it would be root 8x equals plus or minus 3, and it would be fine. And you need the root 8 in there, I think. And then we've got the same answer, because root 8 is 2 root 2. I don't know what else to write. It's only 1 mark. Let's keep going. I think I've written the problem we did. Here is an identity. So the triple equal sign here means these are always the same for every value of x and y, and it's the difference of 2 squares identity. Everyone's favorite identity. Use the identity to work out the value of 193 squared minus 7 squared. You must show your working. Okay, I will show my working. So 193 squared minus 7 squared, according to the identity, is the same as 193 plus 7. Nice. 193 minus 7. And that's 200, and that's nice. And this is 184, I think. So multiply by 200, we could double it and multiply by 100. So let's just do 100 lots of 368. I think that's doubling 184. Yeah. And that is 36800. And that's believable. We're in the sort of, it's 100. It's a very large square number minus quite a small one. And like 200 squared is going to be 4 with 4 zeros. Yeah, I believe it. I believe it. Factorize. Again, out of context, just factorize it. Fine, whatever. Difference of 2 squares again. It's part of question 18. Interesting. Yeah. So this is equal to 10a squared, and this is like this is rewarding familiarity rather than a method. I think recognizing the squares are in there and knowing you're in a context of a difference of 2 squares set up, it's rewarding. It's giving marks to people who have got used to the difference of 2 squares turning up and feel on familiar territory. Anyway, since I know there are 2 squares of difference, so this is going to be 10a plus 9b and 10a minus 9b, and that's it. Question 19. Circle the fraction that is equivalent to 0.1. Well, I know it's a ninth. What are they testing here? Just familiarity with recurring decimals and fractions, which is a good thing for people to get used to. We write numbers between whole numbers in a variety of confusing ways. And it would be tempting, I think, to write this is 1/10, this one, but the dot, it would be 1/10 plus 1/100th. Which would be tempting to write that one, but then it's plus 1,000th because these ones go on all the way into the distance. I know it's a ninth. we could prove it. But if they've done work on recurring decimals and fractions, that should be sort of almost like a bookmark. You can quote that. It's a very useful fraction to be familiar with. Anyway, keep moving. 20. A, B, and C are points on a circle. CD is a tangent. Okay, good. I can't see a centre mark there. I feel like there's going to be an alternate segment theorem, which I'm scraping my mental barrel for. Assume that triangle ABC is isosceles with AC equal to BC. I'll mark that with some lines. Okay. Which means that that angle is the same as that angle. Prove that AB is parallel to DC. Oh, it's a proof question. Nice. To prove it, I would like to say that... Interesting. What are my condition on parallel lines? AB, DC. I think if I can prove alternating angles... So if I could prove that DCA is the same as BAC, we'd be done. But that's the alternative segment theorem. So I feel like I've just got to quote two theorems. Okay, so first of all, it's just writing it down. Angle, I'll write it in words. Angle ABC is equal to angle BAC, and that's because it's an isosceles triangle. I think that'll be enough of a reason. That's definitely true. And so this tangent here means that that angle is the same as the angle in the alternate segment. So it feels like it's almost too quick, but angle DCA is equal to angle BAC. This is the alternate segment theorem. I think that's the acceptable shorthand. And I'm just going to get my head back around that. So I think if you've got a circle and a tangent, yes, that's a tangent, and you've got a segment that touches there, then that angle is the same as any angle that comes off that segment. That's the alternate segment theorem, which is what I'm quoting over here. So I think that's fine. And that means that maybe I didn't even need the isosceles triangles, but so BAC equals DCA mean BAC and DCA are corresponding. So I'm using the inverse of what I think corresponding. If I've got corresponding angles, I've got parallel lines. Does that prove it? I think so. So AB is parallel to DC as required. I didn't think I needed that first line. Angle DCA here is is equal to BAC, and BAC and DCA are corresponding angles, so AB is parallel to DC as required. Yeah, I'm not sure about that one. I'm going to leave it. Maybe I'll come back to that, but I'm just going to keep going for now since let's just rattle through this. 20b, in fact, triangle ABC is equilateral. So all those things are true, and we could put another line on there, but I'm not going to do that yet. Tick two boxes for the statements that must be correct. 2, AB is parallel to DC. Well, that's what we just proved, so that's still true. And AC bisects angle BCD. I think that's going to be true because they're both going to be 60. And AC bisangles BAD. Okay, well, let's draw on it now. So I've got these three the same. So that's 60. 60, 60. And that's 60 because they were the same. And I don't know what that is, or that. Because it would depend where D is, and then it would be different, and that's fine. But it definitely bisects, so these two are the same. AC bisects BCD, is that what it said? AC bisects BCD, yeah, that's true. Let's keep going. Solve the simultaneous equations, the worst named topic in GCSE Maths. They're just equations that happen at the same time. It's just that the word simultaneous makes them sound complicated. They're true simultaneously. The naming of that annoys me. Anyway, really important skill, solving two things. This is weird because we've got 3 unknowns, including the P, and only 2 facts, and that would throw, I think, a lot of students. Hopefully it doesn't throw me. Give your answer in terms of P means we don't have to get rid of P, but we do need to get rid of X and Y, or solve it for X and Y. It looks like it's going to be a candidate to sub in. Well, we could subtract them. Because it's non-standard, I think a lot of students are going to struggle. I'm going to use a substitution method. So y equals 2x plus p. And I'm going to put that in to the other one. 2x plus 3 lots of 2x plus p. And replaced y with the 2x plus p equals 5p. And now I've only got x's and p's, so I can solve this. I'm going to get 5x. Ooh, careful. Careful. 2x plus 6x plus 3p equals 5p. 8x equals 2p. X equals a quarter p. And then y equals 2 lots of a quarter p. I've replaced x for that answer now, plus p, which is half p, plus p, which is 3 over 2p. X is a quarter p, p over 4, and y is 3p over 2. Done. Question 22. Just checking. Yeah, I'm pretty happy with the algebra there. Question 22. A, B, C, and ACD are triangles. We've got some vectors, hooray, with unusually non-integer multiples. K is a constant, good to know. Show that CD is 6A plus 4.5B. CD is the same as C to A plus A to C. Sorry, not C to A and then A to D. D. And C to A is negative A to C, so that is going to be negative 3b. Use the underlines for the vectors. And then AD I've got written there, which is 6a plus 7.5b. Tidying this up, I've got 6a, which is what I expected, and 4.5b as required. And maybe that was more work than I needed to do for 1 mark. But BCD is a straight line. Well, that's also good to know. ABC, yeah, we weren't told that before. Fine. Work out the value of K. So I know that BC is parallel to CD from that. And I know what CD is, so I need to find BC and then make it a multiple of that. So BC is the same as going along up here and then down here, and that's nice and straightforward, is K lots of A plus 3 lots of B. And I need that to be a multiple of CD, otherwise it wouldn't be parallel. So I'm going to use a different, interesting, they've used K already. My instinct would be to use K. I'm going to use lambda, although I'm not sure many GCSE students would use Greek letters here. But that is 6A plus 4.5B. Oh, it's got to be a multiple, and the multiple is clear from here. So lambda is 1.5 to get 3 to turn into 4.5, which means that dividing 6 by 1.5 is going to give me 4a. Sorry, k is just 4. So k must equal 4. Yeah. Is that right? Lambda is 1 over 1.5 there. I've done this a bit weirdly, and there are the lambda over there. luxury of rethinking this. I'm going to say that some multiple of that is that one because it's shorter. And now lambda is 1.5 to make that work. And that would mean k. To prove this, I'd write that 3 lambda is 4.5. So lambda is 1.5. Therefore, 1.5k must equal 6, and k is 4. Yeah, whatever. I got there already. I just wanted to kind of set my working out, and I did get lambda on the wrong side to make sense of it. Keep moving. 23. Simplify some numbers. Excuse me. The irritating division symbol is back. Let's just ignore it by writing it properly. 32 to the 2/5. And I've got to give it the answer in the form 2 to the n. So let's just write everything in the form 2 to the something. So 8 is 2 cubed, and that's then to the power of 4. And 32 is 2 to the 5. I think, yeah, to the power of 2/5. All right, this is going to tidy up nicely. So we're going to get 2 to the 12, multiplying those integers, indices at the top. They are integers as well. And this is going to become 2 squared because you're multiplying 5 times 2/5. And this is going to simplify to 2 to the 10, which is the answer format they wanted. And I'm going to keep moving to 24. F of x is sine of x minus 90. So this is where just drawing a normal sine curve is almost always the way forward, and I'm going to let it carry on a bit as well. That's a normal sine curve, and it has been shifted to the right by 90 degrees. Which means if I got a new colour, it would look, it's going to shift it to the right, so it would do whatever it did, 0 there. And so it's going to hit the peak, the low peak there. So at 0, it's -1. I mean, I could have done sine of -90, and that's the same thing. Yeah, whatever. 1 mark. Should have got that quicker. Question 25. P is a point on a circle. Good for P. Center O. The tangent at P intersects the axes at both points A and B. Okay. I'm going to draw on this diagram because they've given it to me. I'm going to draw it better though. I put point P there. And then I've got this little triangle which I know has 4 along there and 8 along there. Yeah, they're right, it's really not accurately drawn, is it? It looks like it could be 45 degrees and it's not going to be close. But the gradient of that radius is going to be 90 degrees to this one because of a circle theorem. So the gradient of OP is 8/4, which equals 2. Perpendicular gradient of tangent is -1/2. Is that enough? Do I write since tangent to circle is perpendicular to radius at point of contact? I feel like I'm overkilling this, but that's the only reason I can write down, and otherwise it feels like a one-line show that, and the show that doesn't feel like it's got enough justification to get marks. But the gradient of OP is 2, and I think that's probably really what they're looking for, and then knowing that you take the negative reciprocal to get the perpendicular. Okay, whatever. Part B, work out the length AB. Well, let's work out the equation of the line AB, which is y minus y1. It goes through point P, which is 4, 8. So it's 1 minus 8. The gradient of AB is -1/2, and it's x minus 4. Is there an easy way to do this? Well, maybe there is. If I sub in that y is 0 at A, that's when y is 0, yeah, at A. So then we get -8 equals -1/2 x plus 2. Let's tidy this up. -10 equals -1/2 x. X equals 5. No, 20. Get that right. Much more likely. The scale, yeah, it's going to be bigger than 4 and 8 and stuff. And then when x is 0, at b, y minus 8 equals 2. Y equals 10. Could I have got that already? I could have just like counted on the gradient to see where it hits. That's pretty much what I'm doing. The point is that we've got a right angle triangle now with 20 along here and 10 up here. So the length of AB is this square root of 10 squared plus 20 squared. AB length is square root of 20 squared plus 10 squared equals the square root of 500 equals the square root of 100 times the square root of 5, which is 10 root 5, and that's what they wanted because they wanted the root 5 in the answer. Good. And we must be close. We must be close. I should check how many questions. Is that the last one? We are close. We're almost at the end. So to question 26, I think, is the last one. The turning point of a graph, it's quadratic, has x-coordinate -2. 3, 1 is another point on the graph. Work out the y-coordinate of the turning point. Well, let's just sketch the thing. Do not write outside the box. Well, tough. Sorry, I've just been ignoring that the whole way through. The turning point has x-coordinate -2, so let's call it over here. I don't know how high it is. 3, 1, which is there, is on the graph, and it is a positive one. So I feel like it's going to do something like this. First of all, it means that I know that the turning point is x plus 2. Sorry, the equation is that, and I don't know what b is. Let's just dump in the point 3, 1 though. So at 3, 1, we've got y is 1, and that's equal to 3 plus 2 squared plus b. Let's tidy this up. 1 equals 25. That's 5 squared plus b. b equals -24. And that feels plausible because it would be that position there. Work out the y-coordinate turning point. Oh yeah, well it is -24. Right, that's just it. Okay, 3 marks. Okay, it is 1:05. I think we're inside the time. I think I'm just going to stop there without checking. We'll give Tom some lovely mistakes to mark, I'm certain. Did I say I was going to come back and do something? Nah, I'm back to the top now. I've done it in less time. I'm going to check the timer in a moment, and we'll see if I've beaten Tom's time. You saw when I actually finished. I've just been dribbling for a while. But Tom, I'm going to hand this script to you now. I look forward to receiving yours and marking it. And may the best mathematician admit their mistakes honestly and learn from them. Stop the press. Hold the phone. Wait a minute. I did mention stupid mistakes earlier. Among the most monumental stupid mistakes I could have made was not actually checking if I'd finished. I'm going to claim one slight tech glitch, but as you can see, I did scroll down past this question, but it didn't load. I was scrolling too quick for it to have cached the page. There is question 27, and then there is the end of questions. So the timer has started again, and I'm going to do question 27. Yeah, the real piece of paper would have been fine. Angle X is acute. Oh. Cos X is sine 60 times tan 30. Work out the size of angle X. Well, messy. I know about 60 degrees and 30 degrees though, because there are some special angles I should know about at GCSE. Let's just do this. Have I got a pen working? I was working in blue, I think. So copy the question out. In and out, just copy the question. But sine 60, I know how to sort that out, and tan 30, I know how to sort that out. So sine 60 is root 3 over 2. And tan 30 is sine 30 over cos 30, so it's a half over root 3 over 2, so it's 1 over root 3. And that means we're going to get a half. So cos x is a half. And therefore, inverse cos of a half is 60 degrees, or possibly, if I draw a cosine graph, That's 60 or 300. But yes, it's told me it's acute, and that's why it's told me it's acute. There's loads of other options, but acute means between 0 and 90. So x is 60 degrees. And I've shown my working. And that is the end of the questions. And despite my lovely ending last time, now I'm going to hand my script to you, Tom. Please mark question 27. Don't penalise me. But it's fun to do a paper. It is sobering to realise what it feels like when you're being filmed, and I think that's a fair description or a sort of parallel of what it feels like to do an exam when you know your future might depend on it. Doing maths under pressure is very different from when you're just doing maths for the heck of it. I hope you did all right as well, Tom. We'll see how we compare. It's been fun. See you on the other side.